Good day, I am Atika and we are from Group 14. The project title is Blood Sugar Management. Our project focuses on diabetes, a chronic disease that affects millions globally. If left undetected, it can lead to serious health issues like heart disease or kidney failure. We believe early prediction through data can play a huge role in prevention. This kind of project would be useful for hospitals or healthcare startups that want to improve their screening tools. The main users could be doctors and public health researchers, but even patients can benefit through mobile health apps. The key advantage here is being able to spot high-risk individuals early, which not only helps save lives, but also reduces long-term healthcare costs. Moving on to problem statement, the problem we're tackling is that diabetes often goes undiagnosed until complications arise. Using common health indicators like age, BMI, or blood sugar levels, our goal is to build a predictive model to flag at-risk individuals. This can really help with early interventions and better health outcomes overall.
Hello, my name is Anisa and I will present you our project objectives and our project scope. Our project has three main objectives. First, to identify relevant risk factors for diabetes, focusing on commonly available health indicators such as age, BMI, or blood pressure. Second, to model a reliable prediction system using machine learning. This model allows us to analyze patterns in patient data and highlight individuals with a high risk of diabetes. Third, to evaluate the model's performance by using appropriate metrics to ensure that the model works efficiently in real-world scenarios. Our project falls under the healthcare domain, specifically targeting preventive medicine. The scope includes developing a diabetes risk prediction model usable in hospital, clinics, and for mobile health apps. Since diabetes is often undetected until complications arise, early risk identification helps to guide timely treatment, improves patients' outcome, and lowers healthcare system costs.
Hi, my name is Daniel, and I'll be presenting the literature review on the use of machine learning for predicting diabetes. So, the first study reviewed 87 machine learning models for predicting diabetes complication. It found that random forest models had the best performance. The strength of its studies is that it covered many modules across the studies, and then the limitation, however, is that the most studies had high biases and lacked external validation. The next study reviewed research trends in AI for diabetes prediction. It found that traditional machine learning methods were more common than deep learning, and so the study gave a broad view of the research direction. However, the research had limited detail in methods and excluded non-English papers. And so the final paper is that they compared 8 machine learning algorithms using a data set and found that decision trees and random forest performed the best. The research did a direct comparison of models. However, the research had imbalanced data and lack of external validation. Here are some common limitations across studies. These are the references that are used for this literature review.
Description of methodology. It has three aspects. First aspect, obtain, which like the data set comprise both medical and demographic information. The scrap part, which is the process done to clean the data, and the explore part, which we do like the exploratory data analysis. The source of the data for this project is Kaggle, and this is the link for it. However, the specific origin of the data, such that healthcare institution, it's not known. This is a graph. For that, we did 4 steps. First of all, we wanted to see like an overview of the missing values in the data. We did not find any missing value. Second, we checked the duplicates and removed them. Third, we just make a basic check to see the type of the data in each column. And fourth, we ensure that obviously no wrong values in the data. For example, if the BMI has a negative value, which was not the case. Explore part. First, we went with the describe function in Python. We saw the count, mean, standard deviation, and max for each features. So we have an idea of which of the values we were working with. Afterward, we plotted all our feature distribution, and you can see in the age, most people are 80 or at least like over 70. And the most important part is the distribution of diabetic outcome. You can see in the data, 91% are non-diabetes and only 8.8% are diabetes. And the next step, we need to balance the data. Also plotted the correlation heat map to look if there is correlation between the different features.
As for the social impact of the model, firstly is the early detection and prevention. The model enables timely intervention such as lifestyle changes or preventive treatment. Secondly is improved decision making by facilitate doctors and patients with data insight and act as a supportive tool. Next one is optimize resources by prioritizing high-risk individuals and reduce unnecessary procedures for low-risk patients. And lastly, planning and research can help public health agencies identify the risk and aid research prevention strategies. Now we'll take a look into the ethical consideration. Firstly is the data privacy. This dataset is publicly available on Kaggle and is derived from electronic health record. We already reviewed the dataset and confirmed that all data is free from identifiable personal information. Secondly is the use right. To ensure the right, we will include appropriate citation in all academic or public output. Thirdly is biasness. The over or under representation will be later documented to mitigate bias. And lastly, clinical reliability. We will align the model predictive features with clinical literature.